Hello, everyone. I got a wonderfully long and nice introduction, but in short, yes, I'm Anindita. I'm currently a solutions architect at Databricks. My background is in software development and big data consulting. I'm very excited to be here today and talking with all of you. If it were not COVID times, I think we would have had a better face-to-face interactions, which is how we have been doing it for the last few years. But this time, it's great that Global Big Data Conference is still able to host it virtually. Today's topic is operationalizing model lifecycle using MLFlow. All of us at some point have experienced these familiar scenarios. A data scientist created a great artifact which blew all the model metrics, but it cannot be reproduced in the production environment where it's truly needed. Or it all works so well during dev and staging, and we did manage to push it to production, but something went wrong. The results are wrong and we need to roll back. Now, these are real life scenarios and we should be able to address it because they do happen. A quick introduction to Databricks for those of you who may not be familiar with it. Apache Spark is the de facto standard in the big data space, and it was created by the founders of Databricks, who then contributed it back to the open source community. So like Spark, the two other offerings that Databricks has open sourced include Delta, Redash, and MLFlow. Now, why am I talking about these other things? Our topic today is MLFlow. It's because there are three main types of data personas on any data platform. And Databricks provides this unified platform to bring all of these personas together so that they can collaborate and drive business outcomes with their data. So for instance, those of us who are data engineers would leverage Delta more to get a solid foundational basis. For the BI analyst, it's going to be Redash with all its dashboarding and visualizations. And for the ML practitioner, it's going to be MLFlow. So today's topic is MLFlow, and that's the one we are going to focus on. It was launched some 1.5 years back, and it is seeing record numbers in terms of its adoption, as you see on the screen here. 2 million monthly downloads, 200 plus code contributors, 100 plus contributing organizations, and that is the power of open source. And we'll see why it is so popular. There are some challenges that we hear from customers across every industry vertical. It does not matter if you're in healthcare or in the aeronautical space or in IoT or whatever the industry vertical, some problems are just universal. ML teams have not standardized their base infrastructure, and each one tries to build components that should ideally be reusable. ML practitioners, and by the way, they're expensive, they spend wasted cycles on setting up their environments, which directly translates to missed opportunities apart from cost implications. So there is no doubt that mature organizations recognize the need for an ML platforms to standardize their efforts, which is why Google has come up with its TFX platform, Facebook has its Facebook Leaner, FB Leaner, and Uber has Michelangelo. However, all of these are proprietary systems. So if you're lucky and to be working in these organizations and using it, great. But the minute you leave it, that's it, because it's a proprietary system. MLFlow is interesting because it is the only open source machine learning platform for governance and lifecycle management. This is today's agenda. We'll look at some common challenges in the MLOps space, what makes it interesting, what MLFlow is, and what are the components it brings to the table to deliver on its promise to the entire ML community. And we should have enough time to see a demo. Now, a lot of you may have already seen this picture. Google published this in 2015, where it is trying to articulate that ML is fantastic, it's great, but it's a very small part of the ecosystem where you have to get a lot of the other things right before your ML can actually work. And that heavily depends on a lot of data artifacts, like getting the right data sets, verifying it, feature extraction, serving. And then if you have all these surrounding pieces well sorted out, then the ML code is going to work. I know a lot of us get a kick out of that little red box, but there's a lot of non-glorified work that happens around it as well. So what are these challenges? ML is transforming all major industries, but despite the potential, building ML apps is still complex. In fact, it is much more complex than the traditional software development lifecycle. Despite its potential, It is so complex because it's a continuous iterative process involving many teams. So there's a lot of handoffs. And it is reliant not just on the availability of data, but on sound, reliable data so that the insights that you derive out of this data are defensible. According to Gartner, the three main reasons why analytic projects fail are account of data silos, tool fragmentation, and shortage of technical skills. Now, data silos is where the rage was a few years back, and data lakes came into prominence where you bring all your data together, you break down the silos, you consolidate, you see a 360 view of the data. So that problem is kind of solved. You bring in all types of data, structured, unstructured, semi-structured. The fragmented ML tool space is a little more tricky because you do not want to restrict the ML practitioner from trying out a bleeding edge tool if that is going to bring in a new level of accuracy or throughput into your model. So it would be wrong to restrict the tool set that an ML practitioner wishes to use. What would be better is we standardize the process and provide APIs and integrated UI environments to facilitate better collaboration. And once that happens, the shortage of people skills part will also be addressed to a large extent. Right now, everybody would love to be one of those unicorn data scientists, but very few of us have all the skills necessary to be a good one. I like this punchline here. Data, data everywhere, not a drop insight. So I'm trying to pun on the word insight as an insight that is derived from the data. So data definitely is the new oil. But just because you have a lot of data does not mean that you have something useful or valuable on your hands. You have to be able to translate it into insights that can drive your business to improve its ROI or growth or solve a certain problem. So harnessing this data is an important thing. Just being able to have a data lake and having that data consolidation is still not going to give you enough. And assuming you have the data, you've harnessed it, you've built a model, some of the other things, especially for those of us who are in highly regulated industries, we'll have to answer questions like, can you justify that of all the experiments that you did, you chose the right model for production? Can you justify that the model selection process was robust so that there's no unfairness in the process? Like say it's an insurance industry, you give somebody a loan and you do not give somebody else a loan, but they have very common profiles just because a machine learning algorithm told you to do so. We could land into a lot of trouble there. Can you reproduce the model with absolute fidelity? A lot of our clients struggle with this because this is an experiment. It's truly an art to it. You may be able to get a model, but if you cannot reproduce it in another environment the same way, then it's again a wasted effort. And models, like all other living and breathing artifacts, at some point, they are going to get stale. So you need to be able to detect drift and replace it with a newer version. And sometimes people don't even know what version is currently in production. So to be able to manage that entire end-to-end life cycle of a model, just like we do it in the code world. So Git has become like a de facto standard. Everybody uses it to check in their code. You do your revisions there. If something fails, you know how to roll back. The same thing should also be possible in the model artifact world, because like code, which is living and breathing, your ML artifacts are also long-lived artifacts. So let's take a very quick look at a journey of an ML practitioner. You have the raw data, you do some ETL, you featureize, you train, you score, monitor, debug, and then this process continues because sometimes you have to update your features. Sometimes you get some logs which show some errors. You go back to your ETL job, your model gets stale and you have to retrain. And this was the zoo of the ecosystem frameworks that we were talking about earlier. And you cannot really say that this is the best tool because there is no such thing. Depending on your use case, you would choose one or the other. Then a model runs, but then it has to be tuned to be efficient. It needs to be deployed so that it can have all the monitoring and logging bells and whistles. There needs to be model management. And model doesn't exist alone. So ML practitioner does not work alone. He or she works in collaboration with a lot of other folks. So, and sometimes you build model ensembles, which means your model depends on the output of some other model. And it needs to be done with scale. So we are in the big data world or era, and which means that everything that was earlier fitting into your laptop may not work so well today. And then there is governance. So there's going to be audits. You have to be answerable for the interpretability of your model, which is even a harder challenge. And then we get sophisticated, and I'm just doing this slide to kind of show you how difficult the life of an ML practitioner is. It might look really alluring from the outside, but there's a lot of grunt work. Some of it is ML related, a lot of it is data engineering, data related, and DevOps related as well. And I won't even go to do an eyesight check and ask you to read the bottom line, but as you get into more sophisticated model building exercises, there are other things to consider. Your job orchestration, your dependencies, your CI/CD, your data drift, and are you running on-prem? Are you running in cloud? Is it multi-cloud? You have it. So this is where MLFlow comes in as the open source platform to manage this machine learning lifecycle. So it's not building the model, it's giving that flexibility to you to build the model of your choice, depending on your scenario, depending on your data, depending upon your requirements, but it's going to standardize the process of this machine learning lifecycle. So what are the components? So when we talk about MLflow, what comes to mind? The first thing that practitioners do is they use different types of model architectures to run their experiments. So just like in a science lab, you run experiments. Similarly, here also they have a purpose, they have a goal, that this is the thing that they are after. And if we consider that to be their experiment, then they do numerous runs associated with that experiment. Each time, this tracking component of MLflow is going to record your run. And so that you can go back in time later and query it. And what does it record? What is important? It's just not the model artifact itself, but it's the code that was used to build it. It was the data associated with its training, the configuration, the dependent libraries, and of course, the results. Then comes the projects. So when we are doing our experiments, we are running several of them, right? But then once you decide that this was the best one for your particular case, given the circumstances, you want to be able to take that project somewhere else. For that, you need to be able to package it for reproducible runs later. Sometimes the model serving is very orthogonal to the way a model was created. So for instance, you can create a Keras model, but you can serve it as a Python version of it also, because a lot depends on the consumers, how they want to consume the model. So here, models helps you take the same model artifact, but package it in different flavors for diverse serving environments. And then comes the registry. A few minutes back, we were talking about how we don't even think about Git. Git is the de facto standard for your code repository. So in the model world, we have to have a central repository where people can store these artifacts and its related contents, be able to annotate it. Others should be able to come and discover it, because if a model doing that job already exists, why do you have to reinvent the wheel? And more importantly, when you use this registry as your central source of truth for all your ML artifacts, then from this point, you deploy it into different environments, you manage the versioning of the model. And so you can keep track of, okay, version 2 is currently in staging, version 1 is in production, and maybe at some point, and if 2 does well, I need to be able to promote to production. And if I did, it goes on. So this number is ever increasing unless you decide to retire the model completely or the use case is no longer required. Serving becomes another consideration. So you have built the model, and there are different ways in which you want to be able to serve it. So from the model registry, the most frequent or the most prevalent way we see customers use it is in the form of a batch or a streaming workload. So that means you get data over a period of time, you have it in some form of a table, once a day, twice a day, or whatever it is, you do it in a batch mode. Or data is constantly streaming in, like say from an IoT device or from some other upstream system in a continuous fashion. And as the data is coming in, you need to be able to apply the model on the incoming data, score it, produce the result, make a decision, or store it again for somebody else downstream to consume. So this form of either batch or streaming can be done on a distributed platform so that as the need arises, so as more data comes, the platform can scale and you should be able to grow with it. The other form is real-time serving. Real-time serving is more like REST API based. So you can take it in a container and you can deploy it into cloud infrastructure, which are inherently elastic. Like you can take it to a SageMaker or an Azure ML. You have TensorFlow. You might have even custom web serving. And one of them that is provided right out of the Databricks platform is a REST endpoint, but this is only for testing purposes. For more serious workloads, we would advise that there is benefit in just using a highly scalable VM and going over there. Now, when we say model, it conjures different things in our brain. So what is your definition of a model? So model could mean the source code, the version, the hyperparameters that were used to train it, and architecture. So it could be like a deep learning model. It could be a random forest model. So that's the architecture. The data set, the dependent libraries. So if you don't have any of these, you may not be able to reproduce that model. And then additional metadata is also good. For instance, any key value tags to help guide somebody later reviewing the model or using the model as to how to use it, any additional notes, who the author was, when was it trained, how long did it take to train. So those are all the things that goes in. What comes out of it is a metric. So metric could mean something like an accuracy, a true positive rate, a false positive rate, precision, recall. Those are the kind of things that you get out of creating a model. And then you have the artifact itself. So what happens in the tracking server, which was the first MLFlow component that we talked about, is all of this is getting logged in the tracking server, because what I did 2 weeks back, I may not be able to remember today, but having a record of it, it helps me to go back and search for it and justify that I chose this model because this was the best. And the artifactory is where you're storing the actual model itself. And you do this several times. That is why these are called the trained models. Of these trained models, you promote one of them into the registry, which in your opinion, that was one of the better ones, or one that was the best one. So now from a trained model, it goes into a registered model that's in the registry. In the registry, you give it a name, a version, a schema, and again, some tags or its logs. And why do we do this? Because from this point onwards, the strict guidelines have to be followed. Like if, for instance, the schema has changed, the model may not function. If you are trying to look for an older version and trying to give in some parameters which is not expecting, it might not work. So that is why that is important. And from the registry, you take it into a staging environment, into a production environment, or any other environment. So that becomes a deployed model. And then this process is very iterative. You're going to retrain your model and you're going to redeploy to other environments. But every time you have the discipline to take it from the registry, and you have all these other checks and balances in place, so that even in a production environment, you can say, what was the lineage? How was it created? Can I go right to the source code and the other things that contributed to this? And this is the kind of traceability that sometimes auditors may be looking for. So at this point, we have said that governance is built in. You can pick a model in production and not only identify who created, who approved it, what hyperparameters were established, but also go to that particular version notebook that was used. And this is what I'll show you in our demo. Hopefully I'll get to it quickly. Let's look at what it looks like from a high level, 5,000 foot view. This is the image that I want you to carry with you, because all of that other stuff will disappear soon. This is the whole slew of sophisticated frameworks that the industry is constantly churning out. On this side will be your customer, your business needs. Some will want inline code, some will want containerization, some will want batch and streaming. It goes on. And there are a good number of options on this side. In the middle, this is what we have standardized so that you can take a certain flavor of the model that you have tracked with all its parameters, metrics, artifacts, metadata, and take it into a staging environment, promote it into a production environment. When it gets stale, you move from a version 1 to a version 2, take it into production. If that didn't do well, remove it, fall back onto the older one. So this is the kind of flow that would help simplify the life of a ML practitioner. And the promise of MLFlow follows from there. It is open source. It's part of the Linux Foundation. It is open interface. So it is API based, and there is a CLI as well. It's a command line interface, so you can download into your laptop as well. It should work with any of the ML libraries, algorithms, languages, or existing code, because it is wrapping around it. It is designed for scale, so you can use it in a single user environment, or it can go to large organization. And in conjunction with Spark and Delta, which are some of our other pillars, it can support distributed training and inference as well. It is flexible because people sometimes want certain language, like it could be a Python or an R or a Java. And you could use just one of those 5 components I showed you, like you could use just the tracking because they are also loosely coupled, or you can leverage all of them for your end-to-end lifecycle management. And there's built-in integration with most of the popular frameworks, and I'll take you to the website in just a second. It is universal, so which means you can use it locally. You can host your own tracking server and use the APIs, or you can be in the cloud. You can be completely open source, or if you want additional support, then you can use the managed version, which is hosted on the Databricks platform. And here you get the integrated UI and all the enterprise readiness features. So in short, MLFlow is the open source projects. It's got specs, tools, CLI, libraries, REST API, UI, and most importantly, it has got the community, which means every day somebody is asking for a better feature, somebody's contributing a better feature, and you could also run it on Databricks, which is where I'll show you the managed version. MLFlow.org takes you to the main homepage, and you get a lot of content here. But I do want to point you to the docs. If you go there, you'll start to see all the APIs listed under each of these individual components. And then if we go to our little demo for today, this is what a Databricks notebook looks like for those of you who may not have seen before. On the left-hand side, you've got a way to access your metadata. You can spin up a cluster in a cloud environment. You can schedule jobs. But we will focus on just some of the ML aspects today. So this is a scikit model. It is using a diabetes training data set, and it's going to build a simple model. And these are the 2 important lines. We are saying import MLFlow and import MLFlow sklearn, because we'll use a sklearn library. And these are extremely boilerplate standard code where you're creating some artifacts. So you are breaking down your data sets into train and test, and you're going to evaluate some metrics. There's root mean square error, MAE and R2, R square. So these are the 3 metrics that we are going to compute. And every time we call train, we are going to give it the same data set. We are going to give it some hyperparameters, and it's going to generate a model for us, right? As part of the model, we can either use auto-logging, or we can choose to log parameters ourselves. So for instance, here, I'm going to log my parameters, I'm going to log the metrics, and I'm going to log the model itself. But sometimes there might be some additional artifacts that you want to capture. For instance, if you have a ROC curve, right? And that's very useful. You don't want to go back in time and redo everything just to have the curve. So here, for instance, I'm logging another artifact, and this is just a PNG, like an image file. So you have the flexibility to do all of this. Now, we have our first run. We call the train diabetes. We have a data set, and we call it with 2 hyperparameters. So let me click on this experiment tab here. I ran this thrice, and each time it's going to create this run. So I have my top level, which is an experiment. And under that experiment, I have got 3 runs. So first one was with 0.01 and 0.01. So you can see my alpha and my L1 ratio are here. As a result of the model running, it's going to produce these metrics, which are here. And if I click on this little button here, it's going to take me to the experiment page. And if I click on this one run here, it's going to take me to the individual run. So this is what it looks like if you go to the experiment page, right? It's going to say that every experiment has a unique ID. This is where the artifacts are. I ran it 3 times. These are the 3 runs. I can look into each one of them in detail, or I'll say that let me compare all the 3 models. If I do that, it's going to ask me, what are the parameters or what are the metrics that I wish to compare? And this is a very simple examples of 3 runs, but you can imagine that if you have a lot of runs, this visualization is very powerful because it will help you see your inflection points. Just because you increased one parameter doesn't mean that your model is constantly going to keep getting better. There will be a point of inflection in which it starts to deteriorate. So those kind of things you can look and see very easily here. Let's go back. So that is one useful thing of being able to compare your models. You could also search for it. Like in the search bar here, you can say, give me all the models where my RMSE was less than 1, or whatever is specific to your case. So can you imagine here having hundreds and thousands of experiments and quickly being able to narrow in on a certain set of experiments that were particularly useful for you. Then if we want to go into an individual run, even that run is going to be referenced by a unique ID. It will tell you the date it was run, how long it took, whether it was successful or not, the hyperparameters used, the metrics produced, any additional tags that you may want to slap on it for future reference. And then remember the second component and the third component, which is around reproducibility of the model and creating in different flavors. So if I click on the model tab here, there's a YAML file, which is going to tell me that when the model was being created, these are all the dependencies. So I was using this version of Python. I was using this version of the scikit library, and that all comes with you. Using that, I can take it into another environment. The model itself is available in a pickled file, and there are 2 versions of it. One is because it was an SK model, so I have the sklearn version of it, but I have a very simple Python function of it as well, so it can run anywhere. It's the simplest form in which the model can be run. And remember, we were capturing each of those individual images for the run. So even that we had logged as an artifact, and that is available. You can download it. The model from this point, like let's say this was your best model, right from this page using the UI, and again, all the APIs are also there to do the same thing, you could register the model. So what does registering a model mean? So you have promoted the best trained model into the registry. So in a registry, you have got all these models, which are good models. Somebody has vetted it to some extent. And I have it with my initials here, Anindita Mahapatra, and this is my model. My latest version is version 2. And it seems like version 2 I put only on staging and version 1 is on production. So first let's click on this and see some more details around it. In fact, let's go to my first version and see, I want to promote it. I've done enough testing. Well, this is already in staging. Let's go to the second one, sorry. Let's go to version 2. This is in staging, and I'll say I want to request this to be moved to production. Maybe I give a comment, I say tested, verified, whatever, and I put in a request. Now, if I have the privileges, I would be able to promote it, but this is like a workflow in which if you do not have the authority to push something to production, you will get as a request. Now, because it is me, myself, and I'm the admin, I'll say, yes, I approve it. And this is going to take to production. I'll say, yes, I approve it, and I tested it, and I confirmed it, all of that other good stuff here. And this would get into production. Another useful thing is any audit, any action that I do comes here, and it tells, like if it is a third-party auditor who's going to come in, they can see a list of things that happen, when they happen, who approved it. All of these things are built in. And you can also enforce a schema. So if for whatever reason the schema changes, then you know that your model is breaking because of that. And do you see, like I'm in the registry now, but it is giving me a link to a run, which actually produced the code. So I can click on that, and it's going to take me to that specific run that we were seeing earlier. And it said that, yes, the source code is also available to me. I'm going to click on it and come to a version. This was the second version of the notebook with which I can go right to the code. So that is incredibly powerful. From your production environment, you're able to see what was your version, who created it, and all that other details. And then you keep clicking back to be able to get to the source code that produced it and all the other, 9 yards that have gone into creating it. So let me take you to some of the APIs here as well. I don't think I'm doing too well on time. Is there a question answer session here as well? Or should I stop?
Yes, there is, but there's no question yet for you
I
because
can
I'm
go
thinking
on
people
for a
have to
few more minutes.
digest, and if you do a good, excellent presentation that you are doing, people will have no doubts. Artificially create some questions in their mind. I'm just teasing you.
Yeah, yeah.
And I only see, for example, mentoring. Okay, that's different.
Okay.
And I don't think there's no anything when someone says brilliant to you by one of the
Okay.
attendees.
All right, then I'll take the next 2 minutes to just wrap up this demo.
Okay.
So
Okay.
here you have the model name. And as I mentioned, everything is that I did through the UI, you can always do by API. So you say MLFlow, you call tracking, you get the handle to the client, and then you say create a registered model, right? And then you can choose that I want to use this particular artifact of that model. Like say in this case, I chose the first run and I said, create a model version out of it and push it into production. And now that you have it and all the metadata associated with it is there, if I say, get me a model from a particular stage, like say a production stage, it's going to tell me exactly what the model was. So in production, on this timestamp for this run, using this source code link, and the status is ready, which means it's enabled and is primed to go on the production environment. And this can go on and on. I can decide to take a different model and push it. So this time I chose the run 2, and I showed you through the UI how it is to be done. And this is showing you exactly the same thing, but using the APIs to do the job. So you get the latest version from production because you have upgraded it. Now you see that the first time it was a version 1, and the next time that you go in there, you see version 2. There is one other part, which is the serving side of it, which we will probably keep for another time. I think I've already overloaded you all with a lot of information for today. So thank you very much for listening to me and learning about ML.